Okay, these are the answers or the solutions for the multiple choice section of Unit 2 Stage 1, and this is for June 2009. Okay, let's start with the first question then. Skip through to that. Okay, what is the number 4,806 written in figures? So you've got 4,000s, 800s, and 6. That would be A. I'll whiz through that one nice and quickly. Question 2, which triangle is an equilateral triangle? Equilateral, the clue is in the word, all the sides are equal length, and all the angles are equal length as well. So every single one of these is the same. Okay, question 3. Here is a list of numbers: 84, 32, 162, 85 and 60. Ben is going to write the numbers in order of size. He writes the smallest number first, which is also known as ascending order. What number should he write next? So we've got to be careful that we don't end up making a silly mistake on this one. The best thing to do with these numbers is to write them in order of smallest to largest. So we can see the smallest number is 60. Cross it off as we go so we don't forget any. No, it isn't. The smallest number is 32. That's how easy it is to make a mistake. Okay, the next number is 84. The next number is 85. We've done that one, and then we've got 162. So he's written the smallest number, which is that one, which is the one he should write next. So the next one after the smallest is 60. So the answer to that one is E, 60. Question 4. What fraction of the shape is shaded? This is a 3x4 grid. That means the whole area is 12 squares. We can see that 1, 2, 3, 4, 5 of the shaded squares, or 5 of the squares are shaded, so it's actually 5 out of 12. So we're looking for answer C. Incidentally, if you wanted to write that as a ratio, then you would write it as something like shaded to unshaded would be 5 to 7. The total always being the same as the denominator on the fraction. Question 5. 106 subtract 38. Obviously you could just do this on a calculator, but let's just double check what we've got going on here. So we've got 6 to take away 8 starting in the units column. Can't do that one, so to make life a little bit easier for ourselves, we're going to steal something from the columns next door. Problem is we've got 0 in the column next door, so we've actually got to steal something from both columns. So from the 100 and the 0 tens, we're going to make that be 9, and then we will then have 1 6 there, which is 1, 10 and 6 units. We can now do 16, take away 8, leaving us with 8, and then we would then have 9 in the tens column, take away 3 in the tens column, which would be 68. So our answer here is C, 68. Question 6. Here is a sequence of patterns made of sticks. How exciting. So we've got 1 vertical stick, then 2, then 3, and then 4. And then in terms of the horizontal sticks, we've got none, then 1, then 2, then 3. So what we'd be looking for is the one that's got 4 horizontal sticks and the one that's got 5 vertical sticks. So we're looking for 4 and 5. So that is going to be that one there. So number 6, the answer is D. Question 7. Here are the first 4 terms of a sequence. The rule for this sequence is to get to the next term, multiply the last term by 2, and then add 1. So 1, add 1 times 2 is 2, then add 1 gets us to 3. 3 times 2 is 6, plus 1 gets us to 7. 7 times 2 is 14, then add 1 gets us to 15. 15 times 2 is 30, plus 1, so we're looking for 31. Again, incidentally, there's another way you could look at this. If you found the differences, and I always find finding common differences rather useful, you can also find the next number in this sequence by looking at the common differences. It's doubling each time, so 2, 4, 8. The next difference would be 16, and therefore 15 plus 16 gets us to 31. So sometimes you can see other ways of getting there. Question 8, coordinates. Along the corridor and then up the stairs. Always worth remembering. Or X is a cross, because it's literally a cross, and then Y to the sky. The coordinates of P are how many across? So it's clearly 4 across. Anything that's got a 4, not got a 4 at the start, we can get rid of. So cross out those. We can see that it's 3 up. So we're looking for 4 and then 3. So the answer to that one is C. An estimate of the size of the angle X is... Okay, so this requires a little bit of reasoning. Now we can see here that a right angle would probably look something like that, roughly. And a right angle is worth 90. This angle is clearly more than 90. So we can straight away rule out anything that's less than 90. We also know that a full-on 180 degree line angle is all the way across like that, 2 right angles, 180 degrees. So this is clearly not 180 degrees and not more than 180 degrees. So we can rule out that one, and that one. Therefore, we're left with the only logical choice, which is B, 120 degrees. Which fraction is equal to 1.17? So we're a little bit of basic reasoning tells us that this value is more than 1. So anything that has got a larger denominator than numerator cannot be true. That would rule out these two, because 117 divided by 1,000 is going to give us something less than 1. Same with E, 117 divided by 10,000 is going to give us a value less than 1. A is an easy one to rule out, because 117 divided by 1 just is 117. So we're basically left with 2 values here. Remembering a little bit of place value, we can remind ourselves that dividing by 10 allows us to move the digits, that's how they currently are, and move the digits 1 place to the right. So you'd be left with 11.7. That's not what we've got 1.17. So it's not that one, so it must be this one left over. So that is C for the answer to 10. There's a couple of other ways you could explain that, but I think using place value and ruling things out based on reasoning is probably the most useful. 11. What is 1.5 kilograms in grams? I always recommend writing down, for these unit conversion questions, a couple of known facts before you start really thinking about anything. So 1,000 grams is 1 kilo, 2,000 grams is 2 kilos, and then from there we can make a couple of decisions. Now this number is clearly between 1 and 2, so it's clearly between that one and that one. So we're looking for anything between 1,000 and 2,000. That allows us to eliminate those values straight away, as well as that one, because that one's really, really small. Be careful to pay attention to the decimal point. We've only got 2 values left. One thing we can do here is we can pay special attention to where the digits are, and the 1 and the 5 are right next to each other. When dividing and multiplying by tens, hundreds and thousands and so on, or any powers of 10, the digits stay next to each other. So the 1 and the 5 stay next to each other. They don't split apart or anything. They're two little friends holding hands, or something like that. So we've got D is 1,500 grams. Okay, question 12. Bill buys a cup of coffee and a sandwich from Costa or Starbucks. No advertising intended. The cup of coffee costs 95p. Definitely not Starbucks. The sandwich costs 1.49. What is the total cost? Okay, basic bit of addition. Let's just do it to make sure we get it right, rather than guesswork, because you know who you are. Those people that rush things, they make silly mistakes. Let's avoid that. That's by doing the actual calculation. 5 plus the 9 is 14. So we've got a 4 there, and then the 1 carried there. Just make sure my decimal places are all nice and neatly lined up. I've then got the 9 plus the 4, which is 13 plus the 1 that was carried before. So that would be 14, so that 1 will carry across the next place value. I'm then left with the 0 plus 1 plus the 1 that was carried. So that's this one here. I cross that out as I've used it, £2.44. The correct answer to that one is D. Question 13. Here is a list of numbers. What is the smallest number in the list? A recommended exam tactic for this, in my opinion, would be to write all the numbers vertically, and also adding placeholders to those that have different numbers of digits in them. I'll show you that in a moment. So these are all the numbers that we can see here. And what I'm going to do is I'm just going to stick a placeholder in here and a placeholder in there. Now, sometimes when I look at these sorts of numbers, I try to imagine the decimal points not even being there. And it is, but the number system works in exactly the same way, whether the decimal point is there or not. So I can kind of imagine the first one's 120, then 102, 122, 210, 201. What is the smallest number in the list? I can clearly see that this number is the smallest number in the list, 1.02. Lining things up with your units, tenths and hundredths in a nice, neat vertical column system can allow you to make silly mistakes. Here are the first 5 terms in a sequence. What is the 8th term of this sequence? Well, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. Hopefully you've recognised that these are square numbers. And we can find the 8th term if we want. And then automatically you'll realise that the 8th term in that sequence is 64. If the vocabulary caught you by surprise and you didn't recognise they were square numbers, once again with sequences, a great start point is just to find the differences each time. It's then very useful then to do this and notice the pattern. So you can see they're going up in increasing odd numbers. The next difference would then be 11, then 13, and then 15 and so on. And we can arrive at the solution from a different direction rather than just knowing our square numbers in case you forget and have a bit of a brain fart or a forgetful moment in an exam. Adding 11 onto 25 will give you 36. Adding 13 onto 36 will give you 49, and you can see what's going on here. And then adding 15 onto 49 would give you 64. It's another way of arriving at square numbers. Some of you might not have known or noticed that little difference pattern before. So that's I recommend that for any sequences question. Find out those differences and they allow you to get to target numbers in a different way. Okay, question 15. 63 times 1 plus 63 times 9. This is more difficult, or this is easier than it actually looks. If you've got 1 lot of something plus 9 lots of something, that is quite simply the same as saying I've got 10 lots of something altogether. So I'm basically finding 63 times 10, which is A. This same calculation would work as a little counter example here, just very, very quickly. If you had 72 times 7 plus 72 times 3, you could save yourself a whole load of time by just simply saying, hang on, isn't that 72 times 10? Because there's 7 lots of something plus 3 lots of something, which is 10 lots of something. You'd then just get the answer straight away in your head without actually having to do any calculations. That is clearly easier than that. Which number is a factor of 28? This is a knowledge question. Knowing your factors, classic little factor bug. If you need to, smiley face maybe on this little fella, whatever he is. Okay, there we go. So we've got 1 and 28. Always start with 1. Then I've got 2 goes into it. I know it does because it's an even number. 2 lots of 14. Does 3 go into it? General knowledge tells me that 3 times 9 is 27, so it's not going to. Does 4 go into it? Check my tables. Yes, it's 4 lots of 7. And I automatically know that 5 doesn't go into it. And neither does 6, because 6 goes into 30. So I can see all my factors there for 28. Useful for all sorts of factors and prime number questions and things like that. Common factor questions, so I can see that the number that's a factor is there. B equals 7.